Okay, welcome everyone. So in this video, I want to explain how 8051 communicates using serial communication UART. So 8051 is an 8-bit processor where 8 bits are processed at a time. While communicating with external devices or processors, it needs to send or receive data. So for operation, we already know that each memory location is having 8 bits. So these 8 bits are to be transmitted. If all the 8 bits are transmitted at a time, we call it as parallel communication. And if each bit is transmitted once, 8 bits, one after the other, out of 8 bits, LSB bit first, and then the next bit like that. So if bit by bit, each bit is transmitted at a time, we call it as serial communication. So in order to control the operation of the serial communication, there are two registers associated with UART. One is SBUF and the other is SCON. SBUF is nothing but it is a buffer. Whenever you want to send any data from your controller to the external world, you need to place that 8-bit data in this register. Then it will be sent bit by bit. Similarly, if you are receiving any data, the data will be receiving bit by bit. Once 8 bits are received, we need to copy the data which we have received and then make the S buffer available for next 8 bits to be received. Okay. And the SCON means control. Just like timer, there are different modes of operation. So in which mode we are operating the serial communication will be decided, and when to start and when to stop will be controlled by using this register. So in for timer, we have two registers, one for control and one for mode of operation. But for in serial communication, both will be done by using a single register. Okay. Now, what are the different modes of operation? So there are 4 modes: mode 0, mode 1, mode 2, mode 3. In each case, in each mode, the data which we are sending is always 8 bits. Okay. But in two modes, there is one more bit, extra bit, which is meant for error checking like that, parity checking like that. An additional bit is sent along with the 8-bit data. Okay. So in mode 0, mode 1, only 8 bits, and mode 2, mode 3, 9 bits. Okay. So how our SBUF register is only 8 bits. Then where to accommodate that 9th bit? That we will see in detail. Okay. And the next term which we are going to see is baud rate. Baud rate means we are sending the data. At what speed we are sending? How many bits you are sending per second? That we call it as baud rate. Okay. Now, out of these 4 modes, in 2 modes, the baud rate will be decided by the settings you made in timer 1. And in the other 2 cases, it will be decided by the crystal frequency you are connecting. Okay. So what is mode 0, mode 1, mode 2, mode 3? We'll see in detail. Okay. So SM0, SM1, these 2 bits will decide mode of operation out of these 4, and SM2 will decide whether your microcontroller is communicating with a peripheral or is it a other processor, multi-processor communication. This will be enabled by SM2. Okay. Now, what are the remaining bits? In timer, we have seen an overflow bit, TF bit. Whenever overflow is complete, overflow occurs, that bit will be set. So that we came to know that overflow occurred. Just like that, in case of communication, you are sending 8 bits or receiving 8 bits. So once you start communicating to other, if you are sending means transmitting 8 bits. After 8 bits are transmitted, you need to place the next 8 bits. So you need to know whether the 8 bits you have placed in the SBUF are transmitted or not. This will be monitored by using this TI bit. If this TI bit is high, it means your 8 bits are being transmitted. You can place the next 8 bits. Similarly, RA, receive, receiving. This is meant for receiving. So if this is high, 8 bits are received. Copy the content in the test buff and start receiving next 8 bits. Okay. TI is monitoring for transmission. RA is monitor for receiving. Then what is this TB8 and RB8? In this mode 2 and mode 3, we are saying that 9 bits are transferred. So what is that ninth bit is this TB8 and RB8. If you are receiving data, the receiving 8th bit will be RB8, SBUF plus this RB8. If you are sending 8-bit data, the data you are sending is SBUF plus this 9th bit. Okay. And REN, receive enable. So transmission means you are sending. If your processor has to receive, this REN bit is to be enabled. Okay. So transmission, there is no separate specification because once 8 bits are transferred, you need to manually place the data. Otherwise, no, the same data will be there. But whereas receiving, once 8 bits are received, unless you have copied this somewhere else, the next data will be coming outside, coming from the outside. So we don't know when it will come. Okay. So that's why receiving is to be enabled. Transmission is by default, it is enabled. Okay. So whatever explanation I have given, it is explained in this slide. Okay. Now, how it is operated. So first, the baud rate is to be fixed. So as we seen earlier, the baud rate will be fixed by timer 1 in case of mode 1 and mode 3. So what is, how it will decide the baud rate? So to decide this baud rate, this timer 1 is to be configured for 8-bit auto reload mode. That means mode 2 operation. Okay. So that's why this TMOD register is to be loaded with 20H, indicating that timer 1 is 8-bit auto reloaded mode. Okay. And the TH is loaded with a predefined value. Okay. What are the values to be loaded? We'll be seeing in the next slide. Future slides. Sorry. That slide is not there. Okay. We'll see later. So if you load with -3, it will be 9600. If you load with -6, it will be 4800 baud rates. So for different baud rates, there are fixed values to be loaded in this TH1. So in these first 2 steps, we are fixing the baud rate. Okay. And the SCON register is loaded with 50H, indicating that mode 1, 8 bits of data we are sending. Okay. TR1 equal to 1. So we are setting the TMOD and TH registers, but to operate it or to start it operation, we need to start the timer. So that's why TR1 is set to 1 to start the timer. And TI is cleared. So what is TI bit? So TI means earlier we have seen once receiving is over, it becomes high. So to start, once transmission is over, it becomes high. So to place the data, we need to make it 0 and we place the data on SBUF. Again, it will transmit. Once transmission is over, it will become high. So TI becomes 0 to high by the processor. But we need to make from high to low to place the data in SBUF. Okay. Similarly, RA. So the character byte to be transferred serially is written in SBUF. So once you make TI equal to 0, place whatever data you are going to send on SBUF register. Then you need to monitor this TI bit. So you have made 0 TI before loading the data. After loading data, the process will automatically start. Not only loading, if you do any operation on SBUF register, its transmission will start. Once 8 bits are transferred, this TI becomes 1. So we need to wait until this Ti becomes 1. Means while Ti equal to 0. Okay. If it is assembly language program, these are the instructions. So to transfer the next byte, what is to be done? We need to load the next value. We need to make Ti to 0. Load the value. Wait until Ti becomes 1. Once Ti becomes 1, go to step 5, means again make Ti equal to 0, load the value. This process will be repeated. Okay. So different modes of operation. So in mode 0, whatever data we want to receive or send, we need to place it on RxD. This is for receiving or sending. Data will be on RxD pin only. The TXD is meant for clock. Data is sent along with the clock. No need to specify the baud rate. In mode 0, if you observe, baud rate is not decided by timer. Okay. Mode 0. Even for transmitting or receiving, data is placed on only RxD line. TXD is meant for clock. So once receiving is over, RA becomes 1. Once transmitting is over, TI becomes 1. The transmitting or receiving data is placed on RxD pin and clock is placed on TXD pin in mode 0. Mode 1. So what is mode 1? There is TXD and RxD. Both are separated. Okay. So whenever you are receiving data, the receiving will be from RxD pin. Whenever you are sending data, the data is to be sent through TXD pin. Both are separated. Full duplex is possible. So whenever transmitted, TA becomes 1. Whenever received, RA becomes 1. So how the data starting is implemented? A high to low will be treated as a start, and low to high state will be treated as stop. Start bit, 8 bits of data, stop bit. Between start and stop, at a particular baud rate, these 8 bits are sent. Similarly, receiving, start, receive 8 bits, stop. So between start bit and stop bit, at a particular baud rate, these 8 bits are received. Once 8 bits are received or transmitted, this TI or RI becomes high. And mode 2 and 3, 9 bits, same thing. After the 8th bit, TB8 in case of transmission, RB8 in case of receiving. This additional bit will be sent. Okay. So mode 3, the same, the difference will be the baud rate. So baud rate will be not decided by timer 1 in case of mode 3. Okay. That is the different modes of operation of serial communication in 8051. Thank you.